All right, in this section here, what we're going to be looking at is we're going to be looking at the CAPE Unit 1, Paper 2. We're at question 2. So we're at question 2. So here it is. We're looking at A, B, and C in this section. So it says here, let f of x, which is equal to 3x plus 1 over x, and g of x, which is equal to e to the negative 2x plus 1. All right, so let us say we have that. Show that the inverse of f of x is 1 over x minus 3. All right, so for this one, when we're doing the inverse of any function, there are certain things that are required and that we will be doing right about now. So the concept of the inverse is I'm just gonna say let me get a bigger marker. All right, 3, hold on guys, let me get, all right, so let f of x equal to y. So I'm going to say let f of x is equal to y. So now I'm going to rewrite. So basically then y is equal to 3x plus 1 over x. All right, when we're doing the inverse of a function, what we're going to do is that we're going to simply switch x and y. All right, so wherever x is, I'm going to put y, and wherever y is, I'm going to put x. So here we have it. X is equal to 3y plus 1 over y. So there it is. We would have switched x and y's, and then we transpose for the new y. So basically, I'm going to multiply both sides by y. Yeah. So I'm having on the left side here, I'm having xy, which is equal to 3y plus 1. This would have cancelled itself. So I'm going to collect all my y's on one side. So it is my intention to get this positive 3y over here. This is going to be a negative. So we're going to subtract 3y from both sides. So I'm looking at xy minus 3y, which is equal to 1. So I subtracted the 3y from both sides. At this moment, what we want to do is that we want to simply factorize out the y. So if I have xy minus 3y, which is equal to 1, if I factorize out my y, because I'm factorizing for y, so if I take out y, I'm going to have x minus 3, which is equal to 1, and then if I divide both sides by x minus 3, then finally I'm looking at y is equal to 1 over x minus 3. And then you could see that the inverse of f of x is equal to 1 over x minus 3. Hence, we would have proven that. All right, and that's what we were required to show, that the inverse of the function x is 1 over x minus 3. All right, let's move on to see what the other question is about. The next question says that hence or otherwise write an expression for the inverse of g of x. So what we're going to be doing here, it is to simply put the g function in the inverse of f of x. That is all we're going to be doing. If you want to write it another way, basically we're saying that that is the inverse and we want to have the g function in here. All right, so that's the idea. We are putting the g function in that. So let me get the f of x, the inverse function. The inverse function is 1 over x minus 3. All right, so if you want to quickly verify that, you could quickly just swing back to look 1 over x minus 3. So there it is. So what we're required to do here is to do the composite function, the inverse of. So we want to have the g function in the inverse function right there. So we're going to put the g function anywhere we see the x. So right here, we're going to have the g function right there, minus 1. So basically at the end of the day, it's 1 over whatever the g function is. So the g function is e, I think it's e to the minus 2x, yeah? E to the minus 2x plus 1. So we're going to put that right here. So it's 1 over, so it's going to be e to the minus 2x, and then there's a plus 1, and that is the g function, and then we have a minus 3. So what we want to take into consideration that this is my g function here, all of this is the g function, right? All right, so what we want to do now is just to finally simplify this. All right, so it's still going to be 1 over, and then we'll have e to the minus 2x, but the plus 1 and the negative 3 will give us a negative 3. So this is the inverse of f of g of x. All right, so there it is. For 2 marks, there it is. All right, let's continue. Let's continue. So there's another problem that we have here, right? So we have another question coming, and it reads, all right, I think it's up here. All right, there it is. All right, so this is the question here. Sorry about that. So the question is, we're required to solve this problem right here. So it says, solve the equation 6 minus 7 over 2 to the 2x minus 3 over 4 to the 2x equals 0. What I want to do, this looks like a hidden quadratic at the moment. So what we're going to do is just to quickly jump on this here. So I'm going to make something out of this, right? For this, because I'm going to be multiplying throughout, so that I don't work with a fraction, but at the same time I want to establish an idea first, right? So if I'm looking at 4, if I'm looking at, say, 4 raised to the 2x, so let's look at this. 4 raised to the 2x can be seen as 2 raised to the 2, that's 4, and then we have a 2x. Technically speaking, this is actually, I want to have the 2 with the 2x inside, because we're able to move these around. All right, we are able to move these around, and then it's like I square that. Why am I doing it like that? Because I want to connect with this. All right, there are many ways to do it. I'm approaching it this way. In other words, 4 to the 2x is the same thing as 2 to the 2x all squared. I want to appreciate that. So what I'm going to do now is to multiply throughout by 4 to the 2x, which is this. So therefore, I'll have 6, open bracket, I'll have 2 to the 2x squared. Then I'll minus 7 over 2 to the 2x, and I'll multiply that by 2 to the 2x squared minus 3 over, I could write this as that, because I know it's the same thing. Multiply by 2 to the 2x, and this is squared. All right, and this is equal to 0 times 2 to the 2x, and that is squared. So if you notice, everything was multiplied by 2x, 2 to the 2x squared. Everything was multiplied by 2 to the 2x squared. Everything. All right, so now let us simplify these and then see what we have. Technically, I will have 6, and then I'll definitely have the same thing here, 2 raised to the 2x squared. That's okay. Now when I reach here though, some cancelling will be going on. All right, so when I reach here, you would see that 2 raised to the 2x into itself one time, and it's going to cancel the square, leaving just itself there, because this was the square of it. So we're left with 2 to the 2x, and that's fine. This 4 to the 2x is the same thing as this, and it fully cancel. And then 0 times anything is 0. So let us just finally write back what we have. So here I'll have minus 7, and then in bracket I'll have 2 to the 2x. Right? And then I'll have a minus 3 alone, and this is equal to 0. Now, at this point, I'm seeing where I can say, guess what? Why not just let k, or any letter that I want, is equal to 2 to the 2x. I want to do that. All right? So I'm letting k equal to 2 to the 2x. Then I'm going to substitute this idea now. So I'm going to have 6k squared, because 2 to the 2x is k. So it's 6k squared minus 7k minus 3, and this is equal to 0. Looking at this now, my AC is actually negative 18. And we're talking about multiplying 6 times negative 3, and that would have given us negative 18. So quickly, I'm thinking about a negative 9 and a positive 2 to give me the 7. So the number I'm going to be using will be negative 9 and a positive 7. So let's go. 6k squared minus 9k plus 2k minus 3 equal to 0. Now let's just pull out our 3k. 3k into this will give me 2 with a, so it's give me 2 and then with a k, and then this will give me a 3. Then I'm going to have to pull out my 1, so I get back my 2k minus 3, and this is equal to 0. So we're going. All right, let us take stock again. Now then I would have 3k plus 1, and then I'll have 2k minus 3, and this is equal to 0. So definitely now I have factorized this. Now I want to find values for k. All right, so therefore at this time I could say, guess what, either 3k plus 1 equals 0, which means that 3k is equal to negative 1, subtracting 1 from both sides. Then we divide by 3, k is equal to negative 1, negative 1/3. Or we have another option, 2k minus 3 is equal to 0. Therefore 2k is equal to 3. I am adding 3 to both sides. Then I'm going to be dividing by 2. So finally k is equal to 3 over 2. Now we have values for k. Remember that the math didn't start with k. So this is not the solution, right? So what we're going to have to do now is to take this into consideration. Remember that we were the one that said, guess what? Let k equal to 2 raised to the 2x. Now I'm going to have to do back my substitution. So k is equal to that. So if k is equal to 2 raised to the 2x, I have two cases to look at. One, I can say, guess what? Negative 1/3, which is my k here, is equal to 2 raised to the 2x. I'm trying to find x. Now remember, there is no power that I could raise this to so that it is equal to 1/3. So I now would have to log both sides and see what goes on. So I'm going to drop the log into this. So I'm going to log negative 1/3, which I'm seeing that there is a big issue already, and I'm going to log 2 raised to the 2x. Already, I don't need to go any further. Already, we cannot find the log of a negative number, which means that this response is not, it's NA. We're not able to assess this because we cannot find the log of a negative number. So now I'm going to focus on the positive value that I have there. All right, because I'm searching for values for k, but upon the fact that I had a negative number there and I'm logging both sides, I realize that there is an issue for that. Now let us focus on the other response that we have. The other response here says that remember again that k is equal to 2 raised to the 2x. Therefore I could say 3 over 2 is equal to 2 raised to the 2x. What am I doing? I just substituted the 3 over 2 for k. Now I understand how the base system works. I'm not able to raise any 2 to a certain base to get that number. So I'm going to be using my logs, all right? So I'm going to be using logs. So I'm going to log this. I'm going to say, guess what? Let me log 3 over 2, which is equal to the log of 2 raised to the 2x. Now there is a log property that says when I have my power, it becomes a coefficient of my log. So this is going to come around there to assist me. But let's keep this. I'm not ready to find, I could find a value here, but let's leave this for last. But what I can tell you now, we have 2x log 2. Now if you look at this, I'm almost done. I can find x right now. Because let's look, log of 3 over 2 is equal to 2x log 2. I'm going to divide both sides by 2 log 2 There it is. 2 log 2. Let me write this better. Sorry about that. 2 log 2. So this is 2 log 2. So you could see that these cancel here. So at the end of the day, I could just, let me just write this, that x is equal to the log of 3 over 2 over 2 log 2. And that's it. All right, so that's the solution for x. We could put this on our calculator one time if we want, and it will definitely give us an answer. So if we want to log 3.5, right, or not 3.5, log 1.5 or 3 over 2, and we want to divide that, we want to divide that by 2 log 2, it's going to tell us that our answer would be that x is equal to 0.292, and we go on 4.8, and you know, we could stop there. All right, so I'm just saying that that would have been the response that we need as we go there. All right, let's go to the last question. There's another question here that has to do with the factor theorem. So here it goes. All right, here's my question. Thank you. So my question says that the function f of x is equal to 2x to the third minus px squared plus qx minus 10 is divisible by x minus 1 and has a remainder of negative 6, and when it's divided by x plus 3. All right, so x plus 1. So basically, I think I didn't read this properly. This is saying that the function f of x, which is 2x to the third minus px to the square, I should say, plus qx minus 10, it is divisible by this. All right, which means that when it divides, the remainder is 0. It also has a remainder of negative 6 if it is divided by x plus 1. That's what I wanted to say. So basically, we could set up a system here to get a simultaneous equation quickly, and then we just proceed on this. So let's see what this ride is going to be like. All right, let's go. All right, so here's the idea. We're embarking on this idea that if x minus 1 is divisible into this function, then the remainder is 0, which means that if we find f of positive 1, we're going to try find f of positive 1 now. Since this is a factor, then f of positive 1 should reflect the concept, right? So f of positive 1 is what I'm embarking on. So we're saying 2. Let me write this a little better. All right, so we're going there. Let's go. All right, good. So we're talking about 2 raised to the 1, 2 open bracket 1 raised to the third minus p, and x is 1 square plus q times 1 minus 10. This is equal to 0. That's the concept, that if this is a factor, then if we should evaluate the opposite of that number, which is 1, it should give us a 0. So let us carry out this. 1 to the third is 1, so 2 ones 2, minus this is minus p, and this is plus q minus 10 equals 0. So I'm seeing where minus p plus q is equal to, let us bring this on this side. You will have a positive 10, you will have a minus 2, so p minus p plus q is equal to 8. So this is my equation 1. So my equation 1 is what I have right there. So let me go for equation 2. So I could do equation 2 here. Equation 2 is saying that when we divide by x plus 1, we'll have a remainder of negative 6, which means that I want to evaluate f of negative 1. So we'll go opposite to the number there. So when I evaluate this, you'll see what's going to happen. So it's going to be 2 negative 1 to the third minus px hold on, minus p negative 1 to the third, all right, my plus q times negative 1 minus 10, and this is equal to negative 6. So the idea here, all right, the idea here is saying that listen, if we evaluate negative 1 here, we will get negative 6. So let's go. Negative 1 to the third is negative 1 times positive 2, that's negative 2. This is going to give me a, all right guys, I think I made a slight error here. This is a 2. All right, so we're good. So this is a 2. So this is going to give me a positive 1. So I'm still going to have negative p right there. And this is going to give me a negative q right there. This is going to give me a minus 10. And this is going to equal to negative 6. So we have to look. Now I'm going to leave this minus p minus q is equal to negative 6. We'll have a positive 10 coming and then a positive 2 on the other side. Imagine that we want to get rid of these. We're saying at this level, what we want to do is simply, we add 2 here, we add 10 here, so we balance by adding them on the other side quickly. All right, so let us look. Finally, the second equation is minus p minus q, and this is going to equal to positive 6, right? So that is going to leave us with positive 6, and this is my second equation, equation 2. So let us now utilize these ideas to find values for p and values for q. We have 2 equations, so we're going to solve them simultaneously. So let's write them down. So we have minus p plus q is equal to 8, but minus p minus q is equal to 6. Definitely, I'm going to just be adding everything here. So if I add these, I'll get negative 2p. When you add the negative and the positive q, that's a 0, and I get 14 there. Dividing both sides by negative 2, then p right now is equal to negative 7. Now, since I know that p is negative 7, I am able now to substitute that in any one of these. All right, so let us do a quick substitution. We want to substitute negative 7 for p, right? So let us go. Minus p plus q is equal to 8. So there's a minus p. P is actually negative 7. If you add q to this, you should get 8. You're definitely seeing that the negative and the negative, so 7 plus 2 is equal to 8, and definitely you're seeing where q is going to equal to 8 minus 7, which is equal to 1. So we could just write our conclusion anywhere. P is equal to negative 7 and q is equal to 1. Right? There it is. Thank you for watching Daily Maths Concept. If you have not yet subscribed to this channel, please do so and look out for the next video that is coming. Thank you.